Hello and welcome to a special series of Pathology podcasts celebrating National Pathology Week 2010, held by the Royal College of Pathologists. I'm Ben Valsler from thenakedscientists.com, and in these podcasts I'll bring you some of the highlights of this year's Pathology Week. This year's events were focusing on pathology, the building blocks of life. And so this series of 3 podcasts will take you behind the scenes and into the pathology labs at Great Ormond Street Hospital. We'll explore the role of pathologists in pregnancy and paediatrics, as well as getting a glimpse of the world of veterinary pathology and the role that veterinary pathologists play in understanding animal diseases. Great Ormond Street Hospital is a world-renowned children's hospital in London with very close ties to University College London's Institute of Child Health. For National Pathology Week, 6th form students from Furs Platt Senior School were invited into the pathology labs to get to meet some pathologists and discover the role of pathology in children's medical care. Dr. David Wells, the lead laboratory manager, explained just why it was that the labs had opened their doors.
I think really because it's to highlight what pathology does in general, and also being that the National Pathology Week theme was about mother and child, it really was to highlight what we do that's different from other pathology departments around the UK. I think really what makes us special, if you like, at Great Ormond Street is what we do in terms of the mother and baby, particularly the baby, and that's really want to highlight what we do.
So what is it about Great Ormond Street? It has a world reputation as being an excellent hospital for children. The image most people have of that is, of course, of the frontline clinical care of children. What is it about the behind-closed-doors pathology that stands out?
What stands out is our link to that clinical expertise. So we've got the expertise in the hospital on the wards, seeing these patients day in, day out, and then we've got the scientists behind the scenes, if you like, really piecing it all together, relying on the expertise that they have and building up, together with these clinicians who've got that expertise from seeing those patients and bring it all together. Clearly we don't just see patients from Great Ormond Street, we're dealing with patients from across the UK, and we bring that expertise right together into delivering what I hope is an excellent pathology service.
One of the things you have been trying to explain to the students that came along today is the range of careers and roles that you can have working behind doors here. Could you just give me 1 or 2 examples of the sorts of people you need?
Well, the sort of people we need, it's difficult because actually we need every sort of stage of a scientist's career. So we need those beginners, those people who are learning the ropes to come in and fulfil and take over as our people progress and retire eventually. And we need people to come in at different levels to give us those different skills that those different levels have. So, for example, we have biomedical scientists who are graduate entry scientists who are trained on the job once they've got their degree to deliver the frontline, if you like, pathology services 24 hours a day, 7 days a week, delivering those results day in, day out to a high level of quality, but with their clinical acumen as well to make sure those results mean something. And on the flip side, we've also got our clinical scientists who are there to really engage a bit more with the clinical team, to actually have a bit more of a discussion and a debate about what those results mean to that patient. And we're very good at producing results that say, this result is an albumin of 36, but actually what does that mean to my patient is equally important. And both those people add to that. One gives you the result and what it means in that context of that blood sample, and the other one gives you what it means in context to that patient.
You also took those students on a tour of some of the facilities here. What sorts of things were you showing them?
Well, we wanted to show them all the aspects of what chemical pathology here at Great Ormond Street is about, but also what they would see in other laboratories all across the UK, because they're all the same. And it's really looking at the way we use technology to deliver different services. So downstairs in our blood sciences lab, we've got the highly automated, highly efficient, very rapid turnaround laboratory service that gives them the results they need that quickly, rapidly, in the time they need, because some of those patients are being managed in intensive care and they need their results back nice and quick. And then on the flip side, looking at the really manual techniques that take days on end, can be, start an assay up one day and finish it off the next day, and then look at the results over a period of a few days, to show really what the range there is for scientists to do, but also what the range there is that we do to deliver that excellence in healthcare.
And just finally, what did you get out of today? Now, obviously, there are learning objectives for students, and it's very nice for the students to see the range of careers, to see how important all this work is. But you surely have got a busy enough job anyway.
We have, yeah. And I think one of the things that, in my role as sort of the lead laboratory manager, is I've got not only an eye to what happens now, but also an eye to what's happening in the future. And we need to engage people to bring them into pathology, to actually come in, replace the people who leave, replace the people who retire, and grow our new scientists into working in the way that we work in pathology. And really, it's an opportunity for us to take stock about what we do and sell ourselves as a profession, as professions as well, and say, look what we do, look how well we do it, why don't you come and join the team and do that with us? It gives us an opportunity to sit there and say, what is it that we do day in, day out? This is what we do day in, day out. Because you've got to explain it to someone else in that clear terms. And actually, it's nice. It makes you feel, yep, I do a valuable job. It's very easy to get bogged down in paperwork and in sums, which is not my job nowadays. But that's what we do, and actually realise we're doing it for a reason, for the patients at the end of the day.
David Wells. The tour of the labs gave the students a chance to see a range of scientists working with a range of different tools to provide the test results that the hospital needs. Senior biomedical chemist Shazoo explained what happens when they receive a blood sample for testing.
We receive a sample in a form, so it's very important. The first few steps that we do, we make sure that the sample and the form, they match in terms of their name, the hospital number and date of birth. We need 3 forms of ID to accept the sample. If any of these 3 forms are missing, we have to reject the sample. So once we're happy it's labelled correctly, we centrifuge it, so they come as whole blood straight from the patient. You separate the whole blood and the actual liquid component of the blood, so that's the plasma. So this is what we're interested in biochemistry. We analyse the plasma and we look for the chemistries inside there. So once it's spun, we take the sample and the form over to our main analyzers. Once we bring the samples on here, we put it on and we load it on here. There's a barcode reader. Once it reads the barcode reader, it knows what test to do, which patient it's for, and then it starts analysing. A lot of the analysis is based on sort of basic absorbance readings, so it's really straightforward science. But obviously they've done it in a way where it's automated, so you can do loads of the tests. If you try to do it by hand, it will take forever. So it's literally taking the sample, putting it onto a dry slide, letting a reaction happen under incubated conditions, and then checking for colour change, checking for absorbance. You relate that to a concentration of a particular chemistry that you're interested in.
As well as the broad range of tests carried out, Professor Simon Heals brought us onto the topic of metabolic disorders.
My contribution this week, I hope, has been to educate young potential scientists about the discipline of pathology. And the subsection within that pathology discipline is the area of inherited metabolic disorders. Because I think people vaguely have heard about inherited diseases. You don't really get immersed in those diseases until a member of your family gets affected with one. But, collectively, about 1 in 500 babies will be born in the UK with an inherited disease. So it does have the potential to impact on a lot of people's lives, immediate family and beyond. And so hopefully one of the aims is to raise awareness of this group of disorders, an important group of disorders, raise also awareness that it's not necessarily a dreadful diagnosis. It's a challenging diagnosis for the families, but actually, because of the way research has gone on, the way we collaborate with each other in laboratories, we can actually develop very good treatments, not perfect treatments, which can dramatically change the outcome for a child and also for the family. So it isn't necessarily an absolute dreadful piece of news. It's still a hard piece of news to deal with, but actually for some of these diseases, I have to stress some of them, not all of them, there is a little glimmer of hope in that we can actually introduce treatments which can have a dramatic effect in improving that child's life.
So what role does Great Ormond Street Hospital play in identifying and treating these inherited diseases?
Right. Well, Great Ormond Street, I think if you ask people in the UK, name me a famous children's hospital, it's going to be up on the list, People are going to immediately think the Great Ormond Street. Great Ormond Street has this reputation that, well, if every other hospital or doctor can't help my child, Great Ormond Street will be there to help me. The group of disorders I work on are known as the orphan diseases, and I think we all understand what an orphan is. An orphan is somebody who hasn't got a parent, And I think one of the roles that I'm very proud of about Great Ormond Street's chemical pathology is, in a way, we become parents of those diseases. From the lab point of view, we're investing our time and effort into those diseases. From the hospital's point of view, the doctors are working tirelessly to try and improve the outlook and outcome for these patients. So these orphan diseases, in a way, have a home, and I suppose that's what I see the role of Great Ormond Street in my area. It's providing a home for orphans in the form of orphan diseases.
So could you give us a specific example of one of these diseases and how we might be able to go about diagnosing and treating it?
Okay, well, the group of disorders that I get particularly involved in from a scientific point of view are those diseases that affect the normal functioning of the brain. And there's lots of diseases that can actually affect the ability of the brain to perform normally. The group I work on are the group of disorders that stop one brain cell talking to another. That's a neurotransmitter. And there are groups of children that are born without the ability to make those neurotransmitters, and they will have a problem moving and developing. But because we have techniques developed in this hospital and elsewhere, we're able to identify those chemicals that perhaps are missing, and then think about the chemistry that's involved to then try and correct that defect. And indeed, we do correct that defect, and that can dramatically turn around that child's ability to survive out in the real world. But there are other diseases there that are still a huge challenge, working on similar pathways, but we can't quite crack what's going wrong there. We can't quite work out what's the best treatment options, and that's where the research comes in, because some of those diseases are newsworthy, headline-worthy, where we can get big treatment responses, but there are others there that still need a lot of work on them. But, I think we can get there with the right mindset with regards to funding, etc.
And of course, both the clinical side of it and the research side of it relies on having a very good team of talented and capable pathologists.
Absolutely. I mean, the need for a very talented group of scientists in chemical pathology is absolutely paramount. The doctor will make a very good guess of what's wrong with that patient, and it's more than a guess. He's got tens of years of service behind him, and what makes him think that patient, or she thinks that patient's got a particular disease. But there's such an overlap clinically between one disease and another, so you've got to do the chemical tests, and then these chemical tests are done, and the body's not simple. There are many, many, many chemicals present in our bodily fluids. You've got to be able to separate those out and then identify which one's the culprit, and then work out which one is perhaps disease-causing because it's deficient or there's too much of it, and then start to entertain the idea of treatment, where you go back to the doctor and start to have a proper dialogue about the various options. And then we've got the monitoring as well. So it's not a matter of patient comes in, we do one test, patient goes out with a diagnosis. There's a huge amount of talent that we have to draw upon, and a huge amount of equipment that we have to draw upon as well.
How do you feel about seeing groups of students taking time out of school to come in and have a look behind the scenes, behind closed doors, at what goes on here?
I think it's phenomenal. I think it's fantastic. I wish I had that opportunity when I was in the sixth form. I might have worked a bit harder. Currently, I've got 3 teenagers, and I think that we're very focused on exam results, perhaps too much on getting through the hoops. And I think what I hope we've done today is to show relevance to why you're learning those subjects. All my children have studied chemistry. I think they find that the most challenging. Sometimes they say it's a bit boring, but actually when you actually see the chemistry applied, they heard about mass spectrometers today. We've got a lot of them here, and they're essential for the diagnosis of patients. They've heard how understanding the chemistry can actually lead to a dramatic improvement in a child that we presented to them. So I think perhaps some of them became more engaged with their subjects than they would have ever done spending a day at school.
To better understand the tests run to diagnose and monitor metabolic diseases, Simon took us down to meet clinical scientist Helen Fronte.
We employ various chromatography techniques to look at metabolic disease, and these patients have a blockage in metabolic pathways which causes a build-up of certain metabolites. When we interpret those test results, we can figure out where the blockage is happening. Mainly, we look at amino acids in plasma, and we look at urine organic acids as well. Those are the 2 main tests that we do. And these 2 machines behind you here are what we call high-pressure liquid chromatography machines, and we use these to look at plasma amino acids. They all have different functional groups, so they all have slightly different chemical properties, and in that way we can separate the compounds from one another by exploiting some of those properties In this particular technique, we use polarity in order to separate the compounds. So you've got the most polar amino acids come out first, and then the least polar ones come out at the end. And so they're all well separated from each other, and we can also measure how much of the amino acids is in the blood. In particular disorders, you get higher levels of certain amino acids or lower levels compared to a normal reference range for the whole population. So that's the way that we can diagnose certain amino acid diseases. So this machine here behind you as well, we use high pressure liquid chromatography to look at different sugars, and we look in urine and faecal samples. So in urine we're looking at different carbohydrate disorders, and in faecal samples we're looking at absorption and malabsorption disorders or things like lactose intolerance. To detect the sugars we use electrochemical detection. So because sugars can be ionised at high pH, then we can pass them through the cell and they produce a voltage which will give us a response, and that's how we measure those. This is an example of urine amino acid analysis by thin layer chromatography. So in this particular instance we use cellulose acetate sheets and we spot the urine here. We put it in a particular solvent tray and it runs in one direction, we turn it round and we run it in the other direction, so it separates the compounds in two directions, which is called two-dimensional thin layer chromatography. And then looking at the intensity of the spots, we can say kind of semi-quantitatively whether certain amino acids are raised in the urine, and that can give us information about the renal function. And also there's particular transport disorders of amino acids which show up in the urine as opposed to the plasma.
Helen Fronte explaining some of the tests run for metabolic diseases. As well as getting a feeling for the range of tests that the labs need to run on existing hospital patients, newborn screening allows us to spot potential problems before any symptoms even appear. Head of Newborn Screening, Dr. Katie Bainbridge.
The whole point of newborn screening is to pick up babies who have one of the 5 disorders which we screened for, which benefit from early detection and treatment and mean that we improve the outcome, reduce morbidity and mortality.
So what are the conditions we're currently screening for?
We're currently screening for 5 conditions, PKU, which is phenylketonuria, which is a disorder of phenylalanine metabolism, cystic fibrosis, which is a disorder of lung function and also digestion, sickle cell disease, which is a disorder of red blood cells and haemoglobin sickling. We also screen for congenital hypothyroidism, which is a deficiency of an enzyme called thyroxine, and something called MCAD, and MCAD stands for medium-chain acyl-CoA dehydrogenase, and this is an enzyme that's involved in the metabolism of fats and the utilisation of fats as an energy source.
These all are fairly serious illnesses for somebody to have. Why can't we just tell from symptoms? Why do we need to do the screening?
Well, for many of these disorders, there is an asymptomatic phase, so babies can appear completely normal. Meanwhile, there is the accumulation of, for example, toxins which are doing damage and can mean that the brain is not developing properly. And by the time they actually exhibit symptoms and we manage to diagnose the disorders, they can actually do irreversible damage which we can't undo by treating the babies at that stage.
And have they been a success so far? Have we caught enough of these cases to really see a difference?
Oh, it's definitely been a success. Traditionally, we've always screened for PKU and congenital hypothyroidism, and all the babies that we've picked up have benefited from treatment and have lived normal lives because we've been able to treat them early. And that contrasts with prior to newborn screening, where they were, in many cases, in institutions because of their neurological damage and couldn't lead normal lives. And we know that for some of the disorders that we've only recently been screening for, such as sickle cell disease and cystic fibrosis, we're already managing to change the course of the disease. And although we can't cure it, we can improve the outcome, and it means that they're healthier and they're probably going to live longer. And for MCAD, where in the past, if we didn't know that these babies had MCAD, they could suddenly become very seriously ill and even die. We know that by picking them up early, we can make sure an emergency regime is implemented so that we can minimise that, and we're definitely seeing an improvement already.
And how do the pathology labs here at Great Ormond Street Hospital fit into the national process of screening?
So newborn screening is a national programme. We screen UK-wide. There are 16 newborn screening laboratories, and Great Ormond Street Hospital Newborn Screening Lab is the largest of those. We screen over 125,000 babies a year. We actually screen any baby that's born in North London, Hertfordshire, Essex and parts of Bedfordshire.
And what's the future for newborn screening? We've been doing it for 50, 60 years now, but there must be more conditions that we could hopefully catch.
Yes, that there are likely to be lots of other conditions that might benefit from newborn screening. And certainly other countries screen for a lot more disorders than the 5 that we screen for. But here in the UK, we have a newborn screening committee which assess all of these disorders based on internationally agreed criteria. And they look at things like whether there is an asymptomatic phase, what treatments are available and what the potential benefits might be from implementing early treatment, and also whether there are suitable tests and the cost effectiveness of screening. And they're considering a number of disorders at the moment. So I'm sure that in the future we'll be screening many more disorders than the 5 we screen at the moment.
Katie Bainbridge. Simon Heels showed the students the newborn screening lab in action.
This is our newborn screening room. So Katie talked to you about newborn screening and the blood spots, and this machine is drawing up the liquid from that patient's blood spot and injecting it onto this machine here. Now this machine is called a mass spectrometer. A mass spectrometer, I think, in simple terms, can be thought of as a weighing machine. Every chemical weighs something different. We all know the periodic table and how things weigh differently, and I know you know molecules have a mass. What a mass spectrometer does, it separates the chemicals based on how heavy they are. That's all it's doing. For £250,000, it's an incredibly expensive weighing machine, but that's what it is. It's actually separating out different things that they weigh differently. The metabolic pathway took one chemical to another chemical, it changed something on the chemistry, added a hydroxyl group. So it's going to weigh something more than it did before it was converted. And we know how much you should all normally have, and if we go above that level, then we know there's a problem, and we know that patient needs to have the treatment. You might think we're being very greedy to have nearly £1 million worth of mass spectrometers in here. The reason we've got it is we're doing 1,000 blood spots a day. Can you imagine what would happen if that machine broke down? All those patients wouldn't be diagnosed. So we have 2 machines for a number of reasons. One is we've got backup. If that machine breaks down, another one can immediately be switched on. And also we can run 2 sets of samples at the same time, so that every child gets diagnosed as soon as possible, and then the treatment starts on. So this is a very clean area, there's not a lot of scientists here, so different from that lab where I showed you where there were people pipetting away. They weren't actors, they were real scientists that work here every day. This is much more automated, and it's all done by robotics, because this is like thousands of samples a day. That's about 10 or 20 samples a day, but there's much more work involved in running those smaller samples for an individual than it is over here.
Speaking for myself, I felt honoured to be invited behind closed doors at a wonderful hospital that I've known about and respected all of my life. Jill Heels, the head of science at Furs Platt Senior School, explained what it was that the students had got out of it.
All they get to do is sit in classrooms and they do the odd practical and they do loads of theory, and they don't really know what goes on in the outside world, because lots of them haven't got parents that are in science at all. But they want to do science later on, but when they say science, they've got no idea where they want to go to from that. All of the children out there are doing chemistry. Quite a few of them are doing biology. So I just wanted to introduce them to one kind of career path, or an idea of several career paths they could go along, just so that they've got an idea of where they're heading. Some of them are year 13, so they're already applying to university, and several of those are going to be doing applying to do chemistry or biomedical sciences. So for them, it's maybe giving them a little bit more to write about when they're filling in their university applications. And for the year 12s that are here, they've got no idea what they want to do, so hopefully it'll give them an insight.
Great Ormond Street Hospital has an international reputation. But we're looking at not really the public face of it. We're not looking at the immediate patient care. We're looking at the stuff that goes on behind the scenes. Why do you think that would be a useful experience, a useful sight for them to see?
Because people don't realise what goes on behind the scenes. As one lad just said, he didn't expect the hospital to be like this at all. I said, these are the doors that you're never allowed to go through. And they're also surprised that, when a scientist does a test for a disease, I think it's like dead easy, give a blood sample. They've got no idea what happens. They just think that suddenly you get an answer to a disease. And going round has helped them realise that, for maybe to diagnose one disease, you've maybe got to run about 10 or 15 tests to be able to do that. So it's been a really good insight for them. It's been a really good insight for them to see how many different kinds of people work behind those closed doors to help the medics on the front line to give that proper diagnosis to the patient. So it's been brilliant, I think, for them from that point of view.
And the students explained what it was that stood out to them.
It's a lot different to how I expected it to be.
I thought just experiencing it, really, because you see a lot about it on the telly and everything, but when you're actually here, it's quite different.
Mostly the amount of testing gone into just a single diagnosis or something for a patient, that's kind of surprising. I thought it would just be much quicker. So the doctor just look at you and go, this is what's wrong with you, instead of going through all these tests.
That's it for this podcast from National Pathology Week. Please join us for the others in this series, where we'll be exploring the role of pathologists in pregnancy, and we'll be investigating the world of veterinary pathology at the Natural History Museum. You can find out more about National Pathology Week online at nationalpathologyweek.org, that's all one word, and you can visit the Royal College of Pathologists at their website, that's rcpath.org. I'm Ben Valsler from thenakedscientists.com, and thank you for listening.